Hi, right, let's start from scratch here. So again, this is a short explanation how simulator I/O works. It feeds into the criteria, the beta criteria. It's unit 24P8, so that's what you need to do it for. The criteria states that you need to have three different gates on a simulator and create a truth table and analyze it. Okay, I'm just gonna go right to the beginning. So you start off with simulator I/O. Let's go there. And you come up with this page here, and it just goes here, create a new logic circuit. So you've got your logic circuit here, and it's fairly straightforward to use. The symbols are slightly different, so you need to just rethink. But it tells you right at the bottom what symbols you're dealing with. So we've got an AND gate here, you've got an OR gate, an XOR gate, and a NOT gate. And what is this? This is just a buffer. And then we've got our inputs here. So you've got an input, a basic input, which you can manually put in. I'm going to show you later. And then this one is the output. So what I'm going to do is I'm going to have three random gates. Just going to stick them on. And then we create a truth table, or we can create a truth table based on the inputs. Okay, we're going to start off with an AND gate. So all I need to do is you click on the AND gate, left click with your mouse. Then you go somewhere on the grid, so somewhere here in the middle. And then we stick one there. So we want an OR gate as well. So we've got an OR gate, stick it on here. And let's use a NOT gate as well. So we've got a NOT gate here, and we're going to stick it somewhere here in the middle. And then for the output, we want to have something to combine all these three gates. And let's go for an OR gate. And we want three different inputs. And if you look at the input count, you can see this here. So I can increase it to 3. And I'm going to just click here on the middle. And I've got my three inputs. Okay, notice that whatever is highlighted up here, when I simply click anywhere on the grid, I'll get like another gate. Let's click another gate here. So, and if you've made a mistake and you click one gate too many, the easiest way is to just go to this little arrow up here. So it's on the top left-hand side. Click on there, and it just goes one step back. Okay, now we want to. Let's say we want a NAND gate and a NOR gate. How do we do this? We go onto this tool here. You can see this up here, and it says Add Wire Toggle Negator tool. And so to toggle the negator, you just go on the output or the input or wherever you want to negate, and you just click on it, and you see there's a little ball here, and that's a negator. Let's have a NAND gate here, and we're going to turn this into a NOR gate. Try again. And here we go, we've got a little dot there, and it tells us it's an OR gate. So now we need our inputs as well. Let's go for 3 inputs. So we're going to click on here, basic, and it says down here, switch, basic input element, output connector is the middle of the element. In simulation mode, click on it to toggle the input. Yeah. So when we click on it, it goes from 0 to 1, 1 to 0. Okay, so we have got 3 inputs. Put one here, put one there, and put one there. So we've got them all. Right, I look at these inputs, and one of them is slightly offset. Let's correct this. So I can go on the selector tool, or select tool, and then I can just push it up a little bit. Are we in the middle now? We're in the middle now. Near enough. Okay, the last one is I need to connect everything together. So, and that's again our negator tool. So if I just click on it, like click, it'll negate wherever I am. But if I click, hold it down, and drag, then you can connect a line. So let's try this. I'm clicking down, I'm holding down, and I'm dragging it. Dear, I missed it there. Try again. And we've made a connection. So we're going to do the same down here as well. And I can let go, and then it just stops, and then I click down again, and I go right there to the input. The NOT gate, we just connect it to the second input. And I'm just doing it randomly, so I've got no idea whether there's any point to the circuit or not, but that's the whole thing about research. So you find it out later to see whether you get a logic 1 at any one of these stages. So the second input of the OR gate, or the first input of the OR gate down here, I've connected it to the first input, and then I connect this. Accidentally negate it. Can you see? I didn't meant to do this. So I'm just going to go on the reverse button, and it takes it out again. Okay, so we've done all the connections. So now we need to connect it to the last module. So I'm going to do this here. I let it go for a moment, and then we're going to connect this. Yeah. Going to do this here as well, so we're going to go down a little bit. Connect it to this one, and then the last output. Connected to this one, and we need an output as well, so we're gonna put one here. We have to connect it. We go back to our gates, and we've connected this. Okay, so now in theory, providing we've done everything right, and we have to make sure that all the connections are right, it should work, and we should get an idea of what we get. So I'm going to go to run. And you're supposed to create a truth table. Again, a truth table, so you start off with 0, 0, 0, 0, and then you toggle, so it's 0, 1, 0, 1, 0, 1, 0, 1 in the first one. Second one is 0, 0, 1, 1, 0, 0, 1, 1. And then the third one, it's going to be 4 zeros and 4 ones all the way down. So in total, you should have about 8 different variations. Okay, so I'm just going to give it a go. I'm just going to show you how to do this. So we are going into run mode, so it's now running. So right now we can see there's no high, there's no output. So I'm going to click on the first one, and we don't have an out here. So that's, what have we got? We've got an OR gate here. It should give us an output. It's negated here as well. So it's only when there's no logic 1 on here that we get an output. Okay, so I'm going to click on the next one. Yeah, going to click on that one. Don't get one. Okay, let's do a binary count and see what we get. So we're gonna start off with 0, 0, 0 in our output. Then we've got 1, 1, 0, 0, nothing. Then we've got 0, 1. Nothing, then we've got 1, 1, nothing, no positive output. Then we've got, put this to 0, we've got 0, 0, 1, nothing. Then we've got 1, 0, 1, nothing. Then we've got, that one is 1 up, still no output. Then we've got that one. Have we done all 3? So basically, I don't know whether I've gone through all the different variations, but it's just to show you how to do this. So you've got a truth table, or you have to create a truth table, and you can find out, in what combination you will get a positive output. So I don't know whether this circuit works. It looks like it doesn't work very well, but who cares? But that's the way. The main thing is, and that's the main exercise here, is how to use Simulator I/O. Can you save it? I think you can create a link. Permalink to a snapshot. Not sure, quite sure how this works. Create a snapshot. So you've got a link here, for example, and you can go back to this to this thing here. Okay, that's all. Hope this is of help. And you can just try it out, experiment a little bit with Simulator I/O, and you will get. I'm sure you'll get the hang of it. Okay, that's all. Thank you for watching.